Hello, in this video we study center of mass. We'll use double integrals to find the mass of some lamina. Okay, so let's consider the following picture. You have some function f and g right here, okay, and you consider the difference between f and g on some interval a and b. So we have the planar region R. Okay, suppose that you have some planar lamina. Okay, this is just planar lamina. I remember in calculus 2 we already studied such object. We study the mass of a planar lamina with some density functions rho right here. And the mass is nothing but the product of the area and the density, right? If we use the double integral to find the area, that is nothing but, A is equal to double integral on the region R, right? Here we should have rho. And if you bring rho into the integral, you have, the mass is just double integral on R of the density function. In case if the density function depends on the coordinate of a point, like you may think, yeah, that is double integral of R rho x and y dA. Makes sense? That means if your lamina is not uniform, that means the density depends on the coordinate. Means in this point maybe you have density different to the one right here. Let's consider the following example. Suppose that we have some triangular lamina with vertices at 0, 0, 0, 3 right here and 2, 3. Okay, and the density function rho is 2x plus y. They ask us to find the mass of this lamina, right? And now we use this formula. To find the mass of this lamina. By that formula I have the mass m equal to double integral on R 2x plus y dA, right? And now you may choose to write this integral in the order dx dy or dy dx. We learned about that in the previous two videos. Okay, so whatever you want, let's pick one of them. If I want to choose the first approach, I write this double integral in form of iterated integral, and I integrate with respect to the x first, right? The guy inside, right? And then I integrate with respect to the y. So in this situation, I need to fix y and I have to find the interval of x. Makes sense? All right, look at this. Let me rewrite this in here, r. We don't need r in here. I need to find integration limits. So 2x plus y dx dy, right? We know from this picture, y goes from 0 to 3, right? That is the interval of y. So I already have 0 and 3 right here. Now I fix y and I need to find x. In order to fix y, let me erase this. In order to fix y, I draw some horizontal line that is for some y, that intersect with this straight line at some point right here. And we see actually x goes from where? X goes from 0 to this point. Makes sense? So we need to find the coordinate of this guy. Okay, but that is the intersection between the horizontal line y, right, equal to y0 or y. Makes sense? And this straight line. And this straight line. We need to find the equation of that straight line. Agree? That straight line pass through the origin 0, 0 and 2, 3. So I can write the equation easily. can write y minus y0 equal to, the slope is what? Is 3 minus 0 over 2 minus 0 times x minus x0. I can pick x0 and y0 are just, 0. So from here I get y equal to 3 over 2x. That is the equation. Passing through the origin and the point 2, 3. So I can find the coordinate right here. Okay. For each y, I have x equal to 2y over 3. Make sense? So x will go from where? X belongs to 0 and 2y over 3 when you fix y. So I can write the coordinate in here. The first one is 0 and the second one is 2y over 3. Okay. Now I just need to evaluate this integral. This guy. Let's do this right here. So I have, this is 0, 3, and then I integrate with respect to the x. I have x squared plus yx evaluated from 0 to 2y over 3. And then here is dy, okay? So I have integral from 0 to 3. At 0, this function is 0. At 2y over 3, I have 4y squared over 9 plus y times 2y over 3 dy. And if we simplify this, we get, let me write 4 over 9 plus 2 over 3. So basically that is 6 over 9, that is 10 over 9, right? So we have 10 over 9 in here, 0, 3, y squared dy. We use the power rule, we get 10 over 9, y cubed over 3, evaluated from 0 to 3. And I just plug 3 into this function, I get 10. And that is the mass of this planar lamina. Make sense? So, the most important is, you remember the formula right here, okay? And you know how to rewrite this integral in terms of iterated integrals, okay? I would like to challenge you, please. Solve the integral in the order dy dx, okay? So I have 2x plus y dy dx. You need to find integration limits in here. If you have any solution, please send it to me for extra credit. In this example, we need to find the mass of the lamina corresponding to the first quadrant portion of the circle, x squared plus y squared equal to 4, where the density at xy is proportional to the distance between the point and the origin. They don't give you the density, so you have to find that, okay? We need to draw it first, right? Need to graph that first. So I have the circle right here, okay? And this is x squared plus y squared equal to 4. So center at the origin, radius equal to 2. But we use only the first quadrant. So I would have the following region. Okay, that is our R. We need to find the density function. Let's say the density function is proportional to the distance between the point and the origin. So if you have a point right here, x, y, you need to find the distance from that point to the origin, right? And then the density is, just scalar multiple. Make sense? So I can write the distance from x, y to the origin, let's say to 0, is square root of x squared plus y squared. We know that. So the density function is just k square root of x squared plus y squared, where k is some constant. Okay, so the formula, the mass m equal to double integral on r. Here we have k square root of x squared plus y squared dA, right? You know, our region is very special. That is 1/4 of the circle. And when we learn polar coordinate, we know that, you know, for such integrals, it's very easy to use polar coordinates, right? So I would write this integral using polar coordinate. I know that x equal to r cosine of theta, y equal to r sine of theta, and x squared plus y squared is equal to r squared. Make sense? Our region in polar coordinate can be described like this. R is, you know, any r greater than or equal to 0, less than or equal to 2, and the theta greater than or equal to 0 and less than or equal to pi over 2, because we consider only on the first quadrant. So the m equal to, I want to write dr d theta, but if you want, you can integrate theta first and then r later. So for theta, I go from 0 to pi over 2. For r, I go from 0 to 2. The k is constant, I can take that out. Square root of x squared plus y squared, that is just r. And don't forget to multiply with the r, right? Because, you know, when you rewrite this in the form of polar coordinate, you would have, you know, f of r cosine theta, r sine theta, and times r, don't forget that, together with the dA right here. Okay, so that is r squared, you know, that is k, but, you know, r and theta, they are independent in this case. We can separate the function, you know. So this integral is just, you know, pi over 2 d theta times integral from 0 to 2 r squared dr, right? The first integral is equal to pi over 2. The second integral is, let's say, r cubed over 3 evaluated from 0 to 2. So that is 8 over 3. So times 8 over 3. Overall, we get 4 pi k over 3. This is how we can use polar coordinates to find the mass. It really depends on, you know, the region of integration. Don't forget about it.